Hi everybody, this is a video for students who are absent on Thursday, March 24th. So we are in Amplify lesson 1.3 and this is going to be a relatively short-ish video, probably about 10 minutes, that's my goal. And I just want to go through what we did today, just kind of as an overview, and there is no homework for you today. Okay, but we've got like 3, I think, key concepts that you need to write down. So be ready to do that. So the warm-up activity, I'd like you to do that and then hand that in. Basically, there is a group of scientists that have been observing a population of meerkats in Botswana, and they noticed that the size of the population has not changed for about 16 years. And there are 2 students that have a claim as to why the population hasn't changed. So all you have to do is just decide who you agree with and then kind of explain your reasoning. Remember, there's no right or wrong answer here for warm-ups. I just want you to do it so that you can start thinking about that problem. Go ahead and pause the video and complete the warm-up and then go ahead and turn that in. Okay, so then we did activity number 2. Activity number 2 is going to be really difficult for you to read. You can't do it on your own, and I probably won't have you do it unless you're really having a hard time understanding the concept. But we had an investigation question that was, how do births and deaths in a population affect its size? So we know key concept number 1 said in a population there are always births and there are always deaths. So how does that affect a population size? And so what we did is I had the kids start with 14 kind of yellow colored tokens, and they put them inside this little circle. And as they decided over a period of time that there was going to be deaths and there was going to be births. And so if there was a death, they would remove the token, and if there was a birth, they would put the tokens back in. So they had to constantly be aware of how many tokens they started with, and they got to choose. They didn't have to follow any kind of a pattern. They got to choose whether to take out 1, 2, or 3 tokens, and they could do whatever they want. So they kept track of 3 different, we did 3 different rounds of this, and so there were 3 different missions. So there were 3 different data charts. Mission number 1 was I wanted them ultimately to make the population size stay the same. So they had to think about how many did they have to take away and how many did they have to add in order to keep 14 tokens in the circle overall. And then mission number 2, this time they had to make the population size increase. And so what did that mean for the tokens as far as how many they took out for deaths and how many they added in over time for an increase? And then mission number 3 was to make the population size decrease over time. So again, they started with 14, and then at the end of mission number 2, they had to have any number above 14 to show that the population increased. And at the end of mission 3, they had to have any number below 14 to show that it decreased. We talked about the word stability. Stability is when something stays mostly the same over time. And when you're talking about population, it's really difficult to say, okay, we started with 14, we end up with 14. Well, when you're talking about the number of jellies, that's really difficult to pinpoint it. And so it's relatively the same over time. So it may not be exactly the same, but like really, really close. And then the word change, obviously, is when something becomes different over time. So then we watched a video that showed this demonstration, and if you go into Amplify and you look in your video resources, or I think it says digital resources, you'll be able to watch the video. But they've got this system set up with this colored water. They have a valve here to add more and a valve here like to close this off. And so we saw it stay the same. We saw it increase, and then we saw it decrease. And the idea is that when organisms are added, like more organisms are introduced, more liquid is added, the population would increase. So this is just kind of a model to help you understand that in order for a population to increase, let me show you this. Oh, darn. Let me show you a slide a little bit later. That might help this explanation a little bit more since you weren't here for the class discussion. Let me show you the first key concept that I want you to write down, and then you can pause the video while you're writing it. A system can be stable even as things are being added to and removed from it. So in other words, if there are births and deaths, it can still be stable if the amount being added and being removed are not equal, then the system will change. So in order for a system to stay the same, it has to be the same number being added and removed from it. Go ahead and pause the video and write that down. So the video used an example of liquid in a container to show that for a system to be stable, the amount of something being added to it needs to equal the amount being taken away. So the valve had to be open about the same that the valve down here was closed, so that whatever was coming in was going out at the same rate. In our model, they also saw the same thing. If the number of the births and the deaths were equal, then the population would stay stable. But if the births and deaths became unequal, then the population would change. So key concept number 3 says, if the number of births and deaths in a given time are equal, then the population size will be stable. Go ahead and pause the video and write that. Something else too, I forgot to mention it. You'll notice that with the key concepts, I've got this red kind of subheading, stability and change. This is the theme for the PB1. I thought I would go ahead and put it on the key concepts right away so you guys can kind of understand what the theme is and then how each key concept fits underneath that theme. Let's go ahead and go on to key concept number 4. If there are more births than deaths in a given time, then the size of the population will increase. If there are fewer births than deaths, then the size of the population will decrease. Makes sense. Go ahead and pause the video and write that one down. Okay, so then this is a good slide for you to help understand that the idea of stability and change will help us investigate the jelly population. We know that the jelly population has experienced a population explosion. There's an increase in the population, very rapid increase in the population. And so if it is changing and it's increasing, it's because more was added than removed. Whereas in a stable population, the amount added and removed are equal. And in a changing population where the population is decreasing, less was added than removed. All right, you guys, that is it for your lesson. I hope to see you on Friday.